Hi, welcome to another edition of Antique Radio Archaeology. Today we're going to be talking about the 4-circuit regenerative receiver designed by a man named Laurence Cockaday. Now this particular receiver is quite unusual because no other receiver has ever, before or since this receiver, operated quite this way. Now before I get into that restoration that I'm about to do on the one that I have in my possession, I would like to kind of go through the schematics and try to describe to the best of my ability how this particular receiver functions. So this is the schematic taken from the book How to Build Your Radio Receiver by Major Kendall Banning and Laurence Cockaday. Now this particular receiver is different from your standard regenerative receiver in that your feedback, which comes out of the plate circuit and comes back and hits this coil here, is not the way a regenerative receiver would typically do it. The way a regenerative receiver typically goes is you have the output of that plate coming back as a coil, which induces the feedback back onto this tank circuit here, which amplifies the signal back to the grid of the tube in order to get your amplified output. The way this does it is a little bit backwards. What you're doing is you're taking that signal, you're feeding it back over here to the tank circuit, and what's happening is you have this circuit here, which is a dampening circuit. And it's kind of parasitic to this one in that what it's doing is it's pulling down that signal to pull that out of oscillation, because the natural state for this with a directly coupled plate circuit is to be in constant oscillation. So by using this dampening circuit, you're bringing it out of oscillation. So instead of bringing it up to oscillation like you would do with a regenerative receiver, you're actually starting with oscillation, bringing it down. And then you're going to use this same parasitic circuit here to transfer the antenna signal from this single coil here, which is wrapped around this one, and induce it into the tank circuit. Now this particular coil down here is really nothing more than an impedance matching coil, or a load, kind of a load coil for the antenna. It allows the antenna to be kind of tuned for a very broad band of frequencies. So it's not as effective as it would be with a regenerative receiver, but it does help. The reason this is called 4-circuit, by the way, is because there are 4 circuits here pertaining to the coils. You have your antenna coil, you have your dampening coil, you have your tank circuit coil, and of course your impedance matching coil here. So those are the 4 circuits it's referring to. Now once that signal is coming through the circuit and passing, it's going to hit this grid leak resistor here, which is actually, it doesn't show this on the schematic, but it's called a Bradley leak, and it has a built-in condenser on it. So 0.00025 condenser to be exact, and this is actually variable grid leak rheostat. So what's happening is that is getting tuned with the filament voltage and the feedback. It's helping to tune this down with the dampening circuit to the point where this is no longer oscillating, but it's still passing the correct signal. So once this is set up, what happens is the signal is just going to pass, and you don't have to adjust that ever again. You can tune this to any other frequencies after that, and you can tune this to any other impedance after that, and even use a different antenna. You will still not go into oscillation because of the tuning you've done here and also on the 2 filament rheostats here for this detector tube. Now, one of the things that makes this thing work is this is using a UX or UV200 tube. Now, if you know anything about the 200 tube, you'll know that it's a non-amplifying triode, whereas the 201 does amplify. So basically it has very low transconductance. If you were to use a 201 tube, you would have, this thing would be in a perpetual state of oscillation, and you would not be able to do anything with it. So you have to use this lower transconductance tube. One of the things that was kind of discovered is you also have to use a very low voltage on that plate, and in this case 18 volts, no more than 18 volts. If you use 22.5 or higher, what's going to happen is it's going to be a little bit too much and you're going to have problems. So that's one of the little idiosyncrasies of this particular radio. Now once it passes, you also have what they use, a grid denser here to help get rid of some of that RF, and then you've got your first transformer. Now once it passes through this transformer, you're going to hit this first amplifier tube, and this is really where your detector stage ends. It includes that particular tube. Typically your detector stage ends here, and you tap off of here to listen to what your detector stage is doing, but that's not how they did it here. So with that, you have this jack right here, which is where you'll get your first detected signal. They use Bradley ohm resistors here in order to tune your volume. So this is a resistance coupled amplifier, and it will couple over to the next stage, next stage, next stage. Now in this particular circuit here, this was the one that Mr. Cockaday had designed. There was an improved version of this later, and Amplex improved it even further by providing jacks that allow you to basically only turn on the part of the circuit that you need when you plug in your plug, and we'll get into that a little bit later. That is the basics of how this particular receiver works, and as you can see, it's not your average regenerative receiver. So let's talk a little bit about the guys that made this particular radio happen. Laurence M. Cockaday, who was born in 1894 and passed away in 1986, had a very similar entry into the radio world as another well-known pioneer, Lloyd C. Green. Now, if you've been following my videos, you know, you should know who Lloyd C. Green is. If not, I will provide a link in the description that references you back to that video if you'd like to learn more about him. Now, Lloyd C. Green worked as an early engineer, then went into the Navy in World War I, and then he entered the publishing world and became the radio editor for the Boston Globe. Mr. Cockaday was an electrical engineer from the railroads. He became a radio instructor in the Navy in World War I, and later became a technical editor for a magazine called Popular Radio in 1922. Now, he's authored several early books, such as Radio Telephony for Everyone in 1922, Wireless Telephony for All, How to Build the Haynes 2-Tube Receiver, and How to Build the Haynes 2-Tube Amplifier in 1923. But it was a book that he wrote in 1924 with Kendall Banning that would be the biggest accomplishment. He would go on to write a number of books on radio and TV, became the technical editor for the New York Herald Tribune, and he was the owner of many patents, and in World War II he enlisted again to eventually retire as captain in 1957. Now, Major Kendall Banning was a totally different person. He was born in 1879 and he passed away in 1944. He was a war veteran and a poet, quite the departure from the radio-centric Mr. Cockaday. But he too was an author, albeit most of his publications were non-technical in nature, but his writing skills led to work as editor for several magazines, including Cosmopolitan, Hearst Magazine, and Popular Radio. Obviously, the latter would be where Mr. Cockaday would enter into their collaboration for this particular radio here. So, to begin with, the coil here sustained some damage. It had broken loose, and I need to get that all put back together. Some of these connections are definitely broke loose. This is broken loose. I think that's the screw for it right there. Other than that, I think there might be a connection or two that's missing here. Here's a wire that goes somewhere. I got to figure that one out. Yeah, this rheostat wire busted loose. This is not loose. That screw is probably that screw there. There's a bunch of these things. I don't know what they are yet. I'm going to figure them out. I think it has something to do with the tuners or tuning knobs. I'll look at that later. But other than that, I'm missing one of the amperite voltage regulators that goes there. So I'm going to have to order that. I'm missing a bunch of these. This is a connector. It came with one. These may look familiar. They're actually, if you've ever seen a spark plug, this is what the top of a spark plug looks like. That's the exact same connector. This here plugs into it, or snaps into it, and that gives you your connection. This is just a screw down connection for your wires, so you can disconnect them and reconnect them very quickly if you need to, but I definitely need the rest of these, so I'm going to find those online and try to order those. Let's see, isn't that screw? Other than that, I'm glad that the faceplate's in one piece. That's the one thing I was concerned about, but it is. And the rest of it's just cleanup, I think. It did come with one tube. It came with a 301 tube that was stuck in this socket. Now the 301 tube is not one of the tubes that you want for this receiver. It's supposed to be operated with a 200 tube in the detector, and the amplifier tube should be 201As. Could be a 301A, but I'm just going to go ahead and stick with 201s, as that's what's is called for in the specifications on it. So that's pretty much it for the condition. So some minor repairs here. Definitely need to order some parts. As soon as I get those in, we'll continue on this. Alright, so my plan going forward here, I'm going to go ahead and try and keep as much of this intact. I'm going to clean this up with a little bit of crocus cloth. If you've never done it, it actually works quite well on some of these old rails. You just got to be careful that you don't go too overboard with it, but it shines them up real nice. The big thing is I just don't want to break any solder joints. Now the rest of the stuff that I have, I'm going to go ahead, all the hardware and everything, I'm going to use the ultrasonic cleaner for that, and then go ahead and clean and polish all the bakelite boards like this one and the faceplate, and that's pretty much it. We're going to just spend a couple days cleaning here, so let's just settle in and get started. Okay, so it's day 2 in the cleaning process. Obviously I've done quite a bit of cleaning here. This is some of the bus wiring here. Here's all the parts that I've already cleaned. Got ready to go, and I'm just continuing. Like I said, this is a definite couple days of work here. So I'll just keep doing what I'm doing. There's only one capacitor over here, whereas these have stacks of 3 capacitors. The reason behind that is the capacitors used here are 0.005 capacitors, and according to the specifications this needs to be 0.015 microfarads. So in order to get 0, 1, 5, you put them in parallel as opposed to series like resistors to get your higher capacitance. So at 0.015 with 0.005 capacitors, here and here, this one here only had 0.05. Now, unfortunately, I only have 1.05 capacitor. So what I'm going to do is this. I've got 2.0025 capacitors, put those in parallel with the 0.05, and that will give me a total of 0.015. So I should be able to go ahead and tie these all together. Now the way I'm going to do that, I think I'm going to just put these 3 together. So I need to solder those. My stack is reading 15.89 nanofarads, which is 0.015 microfarads. Okay. So before I finish this up, there is one little thing I wanted to take care of. There is a little crack right here. It's coming from here over to here. I'm just going to stick some super glue down in there to kind of stop that from spreading. Okay, there's one last thing I can do before attaching the faceplate. I'm going to go ahead and solder that connection right there on each one of these jacks. Okay, so the problem I have with this is this thing here is locked up. It's the vernier, and it's supposed to turn this very slowly, and I can see some gears down in there. Okay, and I'm going to have to fiddle around with this. I want to see if I can take this apart somehow to get down into those gears. So unfortunately things didn't quite work out the way I'd planned. I couldn't get this thing out of here without breaking it apart, and that's what happened. The problem is this large gear back here, as you can probably see, it's been permanently fastened on here. There's no way of removing it without destroying it. So the problem I was having is when I turn this knob, or try to force this knob to turn, what would happen is it would unscrew. and that's not good. So what I did was tore out all these gears, so now it turns freely, but it doesn't do anything. So I can still use the regular adjustment. Now the only difference between this and this one's a good one is when you turn this, obviously it turns the capacitor like that. Now the problem is when you're doing a fine adjustment, what's going to happen is, if you notice, that dial is turning very, very little. So that's what this one's supposed to do, but now it no longer does it. I just went ahead and put it back together, so I'm going to use it as a regular adjustment until I can find a replacement for it. So one of the things that I still have yet to do is this here butts up against the plate, and it spins around on that. Now, obviously, on the one with the vernier, that's not going to happen. So what I got to do is I'm going to go ahead and put these pads on here so that I can use that accordingly. Now the problem I have is I don't have enough of these pads for both of these, which is no big deal because this one I really don't need it anymore. What I'm going to do is I'm just going to go ahead and put a felt washer on there and be done with it. Now on this one though, I'm going to go ahead and glue these pads on there. Okay, so I'll go ahead and let that sit, and I'll install that when it's all dry. So this is pretty much the way it was when I got it. I do need to solder these on. I'm going to hold off on this because there are some issues with how this thing's wired. I can see that just by putting it back together. I'm going to have to take a look at the technical data and see what's going on here so I can figure out what happened and why. And hopefully it should be something easy to resolve. So, alright, so this is the way this thing's supposed to be wired. Now, what I wanted to point out is right here. This circuit here is a standalone circuit. It consists of one coil and one capacitor, and they're tied together. This is the capacitor. This here, the green coil here, is that coil. This capacitor is tied to ground. The other side of it's not tied to anything. The other side of this coil is coming over to the plate circuit here, which is totally crazy. And this other side of the coil is not tied to anything. What I need to do first is get this coil here, which is those are the two ends to that coil, and just tie it to the capacitor here and, well, here actually. And as far as the other side, this other capacitor and this other circuit here, this here is a mess. What I should have happening is this coil here, one side goes to this capacitor. That's the capacitor. This is the coil, which is this large coil here. So it does right here. So I got this capacitor here coming to this coil. Now the other side of the capacitor is coming to the coil on this side, which it does. Now the problem is it then goes and hits that plate and that transformer. So it comes back here, hits the plate, comes over here, hits the transformer. This wire here shouldn't exist. It's tying all this to ground. There's no reason for that. And this is the same wire that's tied to this capacitor. So that wire needs to go away, that wire needs to go away, and that wire needs to go away in order to correct this part of the circuit. This right here. So that's my first step. And then I'm going to keep following through. I'm sure I'm going to find some other stuff. Alright, I took care of that circuit. Alright, so I spent a little bit of time going through this whole circuit, and I drew up a schematic with pencil and pretty much kind of figured out what this circuit's doing, because it's definitely different than the schematic that is for this particular radio. However, there are a lot of variations of this kit, so it probably is correct for a kit. And unfortunately, I don't have the blueprints that came along with it. So I went ahead and drew up the schematic, which I went ahead and put into the computer and came up with a pretty decent idea of what's happening here. And actually, it's identical to this original schematic with the exception of the jacks here. They're using 6-pin jacks over there instead of the 4-pin jacks that are used in the original schematic. So because of that, it took a little bit of figuring out to understand what was going on. It was also missing a power switch, and I still have this thing right here. This right here, I finally took a real good look at it and realized that it's basically putting a resistor in parallel with a dead short, which is absolutely ridiculous. So first off, this thing just needs to come out of here. It serves absolutely no function at all. Now, what I was able to figure out based on this schematic and looking at the diagram here, everything is correct now. What I did over here corrected the issues that I knew about. When I went through the rest of the circuitry, I pretty much figured out that everything is hooked up as it should be. The interesting thing about the jacks is what they've done is they've basically come up with a way of turning on the amplifier by simply inserting a plug. So when you insert a plug into here, what's going to happen is it's going to disable all the rest of these. Well, actually, none of them are enabled. When you plug it in, this is enabled. So it will enable the first tube, and you'll be able to hear the signal just powering up that tube. When you pull the jack out, or the plug out of the jack, and plug it into the next jack, then these two tubes will light up. Again, pull it out, put it in this jack, these 3 tubes, and if you put it in the last jack, all 4 of the tubes will operate. So it allows you to bring up different levels of amplification, and if you don't have anything in any of the jacks, what happens is the set is basically off. So how you turn it on is by putting a plug into one of the jacks. Now that I know everything is good, what I'm going to do now is, I do have some parts that I ordered. I wound up getting a hold of some of these connectors, which they don't perfectly match this one, but I don't care. I still am going to keep the original with it. So I've got those. They plug into there. I've also got the Amperite filament regulator. And what this is, they call it a self-adjusting rheostat. Obviously I don't need the whole thing here, I just need the little part there. So this is called a self-adjusting rheostat, and it's used for 6 volts. All it is it's kind of like a ballast resistor. It has a resistive wire in it that heats up, and as it draws more current and heats up, it becomes more resistive. And as it becomes more resistive, it brings down that voltage level. So basically it keeps from damaging your tube. If you hook up a new battery that's almost 7 volts, it's going to drop it down to about 5. And if you hook up a one that's about 6 volts, it's still going to drop it down to around 5. So they work pretty well, but you know they're limited as to what they do. But anyway, I do have one of these, so I'm going to go ahead and install these, and then I also have this dial that where I glued those on. I'm going to go ahead and put that on here, so let's go ahead and get this thing completed. Alright, I'm going to go ahead and fire this thing up. I've got a speaker jack here that's hooked to a speaker. Here are all my power connections. I got my antenna hooked up. This is my 6 volts, my 18 volts. Actually, this is my 18 volts. And this is my 135 volts, but I'm only doing 90 volts for right now. Alright. I am getting absolutely nothing. Alright, one thing I can check real quick. Let me go ahead. I have a feeling I know what the answer is here. Okay, I'm going to come off the plate of the detector. Alright, my audio sections all work. So I know that everything here works. I'm still not detecting any RF. There's not a lot in the RF section. I have the 2 capacitors here. I have these 2 coils here. I have this coil and that coil. None of the capacitor is the only thing that's adjustable, except for I do have this Bradley thing that doesn't seem to do much. It keeps my squeals down. Yeah, I'm just not picking anything up. So I'm going to check out a couple of things, and then I'm going to see what I can do here. But I do know that this grid denser has the proper capacitance. I know that thing does work. It's reading 0.0005 microfarads. This one here seems to be working. Yeah, I don't know. But let me check a couple things out. I'm going to look at some of the data and see what I can find. Okay, so I did find a couple of things wrong. I did find that the grid capacitor was reading 0.0005, and it's supposed to be reading 0.00025 microfarads. So I went ahead and swapped that out. That didn't correct my problem. I still couldn't get anything. And then I went ahead and went through all the build information on this thing, and I finally figured out that when I got this radio, somebody had switched these 2 capacitors. And one of them's a 0.0005 and the other one's a 0.00035. So that does make a difference, and when I swap those out, I think we've got the problem resolved. So let's just go ahead and plug it in real quick and
27 degrees in Dawsonville at 11:35. More news at midnight. Breaking news as it happens.
Okay, there's one station.
Thing you can always count on. John. A song called The Wait. Tonight's
A real classic by Laurence Cockaday and B. Wayne. I'm
Another
having
one.
music to cram into a little bit of time, so let's get on the ball and tell you guys these tunes.
There's my local station. So yeah, it's working. So I'm going to go ahead and okay, I'm going to go ahead and do some work on the cabinet, get that thing reinstalled, and then I'm going to play around with this a little bit more, get used to tuning it. It's a little bit different, and we'll get into that later, but at least it is functioning now. So I've got the radio we've been working on, the Cockaday Receiver, and I brought in another receiver. This is a Regenerative Receiver, the Chelsea Model 107, which was produced about the same time frame, has the same or similar circuitry. It's also a regenerative receiver that has the regeneration coil in it versus the Cockaday coil. So I want to make a comparison between the two based on the stipulations set forth in Mr. Laurence Cockaday's October of 1924 article in Popular Radio magazine. Now those stipulations are that a radio must produce loudspeaker signals from distant stations. Number 2, must tune in distant stations through local stations. Number 3, produce all signals without distortion. Number 4, not radiate under any conditions. Number 5, cost no more than $55. Number 6, be simple to construct, wire, and operate. And number 7, be the best all-around set for broadcast reception. So let's go ahead and check these two out and see what happens. So let me start off with the Cockaday Receiver here. This is the one that I've got hooked up, so it's already powered.
So let's see how it plays out. But the motion practice is about to get very aggressive. Quick break, Laurel. On the other side, and your phone's coming up 800 941 number if you want to be a part of the program.
Okay, that's an actual distant station here.
Kids are as safe as possible when they are at school. And as a parent, you must ask your child's school safety director if they'll have a knock-entry access system that gets law enforcement into locked doors in case of an emergency. Firefighters have trusted Knox products as their choice for access since 1975, and now the knock-entry system for schools is providing law enforcement with the same resources. You can learn more about knock-entry at schoolentry.com. However, there is a solution. Type Dynamite for free. Just pay shipping and handling. Learn more at dynamite.com/radio.
Okay, there's another station. Alright, and that's my local in-home radio station right there. So it's picking up 3 stations. So the next thing I'm going to do is going to go ahead and put all the power onto this radio here, and let's see how that one sounds in comparison. Okay, so I got this one all hooked up. Let's go ahead and see if we can't get something on it. Okay, that's the local home station.
in droves, and interest rates are too high to buy. People need homes to rent. So smart homeowners are renting their home out on loan for the rest of the fall. You'll want to stay with it. Especially when you hire professional landlords and renters. Find your tenants, collect your rent, and handle your maintenance calls to get a good night's sleep. Vacation. People's jaws literally drop when they hear that Renter's Warehouse also offers a 90-day test drive. If you're not happy, you can fire them with a 90-day
Okay,
test.
this one absolutely sounds good. I've been able to pick up the 2 local stations. I'll try and get that other one.
Degrees in Dunwoody and 74 degrees in Peachtree City. More news at 11 o'clock. Breaking news.
Alright, well, my impression is that this one does sound good. It does only pick up 2 stations, however, so that's really the biggest difference between these two that I can see offhand. Okay, so what do I think? Well, I think the Chelsea radio sounded better and it was a little bit easier for me to tune. However, I will say that that's unfair because I'm very familiar with that radio. I'm not as familiar with this one. It does have a quirkiness about it that takes a little bit of getting used to, and actually Mr. Cockaday does mention that in one of his articles, that it does take some practice to get used to tuning in this set. Now, dialing it in initially obviously was a little bit of work, but once I got it there and working, then the rest of it, as far as doing normal operation, it worked really well. So the sound is not the radio's fault. It's these Bradley ohm potentiometers. They are not holding up well after 100 years. I've got a replacement order. I don't know if that's going to correct my issues. If I were to use this as a regular receiver that I'm using quite often, I would probably replace all 3 of those, and probably also the Bradley leak that's inside of it because it has the same issues. Now, as far as did it meet the expectations that Mr. Cockaday set forth in his article, it did produce loudspeaker signals from distant stations. It did tune in a distant station through local stations. It produced all signals without distortion. It did not radiate under any conditions. It does radiate when you're doing the dialing in initially, but once it's set up, you never should have to touch that. So, not totally true, but for the most part it is. Did it cost more than $55? Not in the day. However, $55 is a lot of money for a radio of that time frame. So, yeah, this was definitely not something the average working guy would have. Now, was it simple to construct, wire, and operate? Yeah, I'd say it was. It really was overall. And as far as it being a best all-around set for broadcast reception, there are a lot of sets out there on the market during that time, and that is really hard to say. I think even the regens, once you get used to using a regen and once you know where the stations are, you're not going to be putting out those squeals that are so common with the regen, and that became a big problem. It was so big that the newly minted version of the FCC was starting to crack down on regenerative sets, which is why the TRF sets started to kick in during this time frame, and some of the other radios of that day or that era. And of course the AC sets were coming online at the same time. So yeah, regeneration was kind of going away, but obviously it came back later with a little bit more control. But during that time frame, it was an issue. So as far as where I'm going to go with this, I'm looking forward to further experimentation and, you know, getting to know the set a little bit. I am going to be working with it. Whether I do another video or not, I don't know yet. But I do know that this is definitely a radio worth looking into if you don't have one or if you come across one. And definitely don't part it out. Give it a shot. Get this thing back to operational and you know, see what you can do with it. So in the meantime, happy restorations everybody. Hope you enjoyed today's video and hope to see you again next video. Goodbye.